Hi everyone, welcome to Vedantu J English. I'm Diksha Mam, your chemistry master teacher. And as you all requested that ma'am, we want VITEEE Triple E session. So here I am. Okay, whenever I promise something, I always make sure that I am on that point, what I promised to you. Right? So I have selected even the last shift that has happened, right? According to that also, if you see chemistry, it is actually very scoring for VITEEE Triple E. Reason being, it's not very high level of chemistry they're asking you. Very moderate level, easy, predictable questions they're asking you, right? And here you can easily fetch full marks in your chemistry section at least, right? So let us start with the organic chemistry questions, and then we will do some important questions of physical chemistry and inorganic chemistry as well. So I have taken most of the questions of organic chemistry. Reason being, if you see my video on this channel only, if you see this over here, right, you will see that there is already I have taken one live, two lives in fact on VITEEE Triple E. You can see even all model questions of English and aptitude Schiff sir has taken. You can also go through this video here, right? And we have taken other VITEEE Triple E session as well. As you can see, VITEEE Triple E most important concepts and question that has crossed a lot of views, right? So you can watch that, right? This is for maths, this is for physics, this is for chemistry. So in this particular part, I have taken inorganic and physical questions along with the questions and the concepts in detail, right? So today I'm going to take your organic chemistry questions. So let us start this without wasting any time. Okay, so everyone have your notebook and paper along with you. So everyone let us join and put green hearts in the comment section for VITEEE Triple E students. Okay. Yes, everyone, Rishita, Raktita, Mopuru, and Sivdesh, Bharani, right? Everybody, let us start this session without wasting any time, right? Okay. First question on your screen, I will start telling you side by side what are the different topics that they can ask you in your exam, right? So first question here is, which is the most reactive towards nucleophilic addition reaction? Right? So whenever we talk about nucleophilic addition reaction, see, these are some of the standard questions, right? Okay. So which one of the following is reactive towards nucleophilic addition reaction? Nucleophilic addition means on the carbon, there should be electron deficiency. If someone is poor, right, then nucleophile, which will get attracted towards something which is electron deficient, right, the rate of reaction will be more in that. So they are asking you most reactive here. So what you can see, most reactive towards nucleophilic addition reaction. So you have to see this carbon, this carbon, this carbon, and this carbon here, which is most electron deficient. That means if someone is taking out electrons here. So here we can see it has electron withdrawing group that is taking out electrons from it, right? Via which things? Two things here, that is minus M and minus I. What about this one? Here it is donating through plus I effect. So donation means more electron density. That means this surely cannot be the answer. Here you have no effect, and in this case what is happening? In this case it is donating through CH3 and it is also taking away the electrons like this. Because the simple part is, whenever on the benzene ring, students remember these two things that will really help you in the exam. Whenever on the benzene ring, if you have a group that has lone pair of electrons, then it is going to show plus M effect. Then it is going to donate the electrons in the benzene ring. Itself, it will lose the electron. It will take away the electrons, right? Okay. Then if you see, you have a group which is double bondedly or triple bondedly attached to more electronegative element. This is less electronegative, this is more electronegative. Always it is going to show minus M effect here. So what it will do, it will show you minus effect here. It will take the electron here and take the electron from the benzene ring, right? So this is plus M and this is minus M. So as you can see, this carbon here is attached to the benzene ring, which is also attached to double bond with oxygen, which is more electronegative. So it is going to take the electron from the benzene ring. That means this is definitely not electron deficient. And here you see no effect. So answer will be D, which is showing you electron withdrawing group here. So answer is going to be D is the correct. Session duration will be 1 hour or 1.5 hour. Okay, only most important questions I have picked here, right? Okay, I know you have less time, so according to that only the session will be. Don't worry about that, right? Okay. Now, next question, let us see that. Next question, students, try to answer the questions also, right? Okay. The product formed in the reaction of cumene with O2 followed by treatment with dilute HCl. Now, all the naming reactions should be on your tips, right? All the naming reactions. If you're thinking, ma'am, I have no idea right now what to do, just go through my naming reaction and important reagents video. Go through that. That is just 1.5-hour video. That will really help you. And I promise you that you will see questions from organic chemistry from there only, right? Okay. So the products formed in the reaction of cumene with O2 followed by treatment with dilute HCl, right? So here we are talking about cumene process. What is cumene? Cumene is when you have isopropyl on the benzene. That is CH, this is CH3, this is CH3, right? Now, whenever you add oxygen here, it has a peroxide linkage. That means this is converted to, this is COOH, this is CH3, and this is CH3. This also they can ask you. Sometimes they also ask that what is the intermediate that is formed here, right? After that, doing the hydrolysis, you get two products. That is, I can see in the options. Second one is acetone. So let us see how many of you have answered it. B. Very good. So answer is B is the correct answer. Dow's process, cumene process, diazotization process, all are very important for you, right? Next is conformers. Okay, so conformers, how to remember, right? First is in ethane and cyclohexane. In conformers, they will ask you questions from stability only, right? Okay, so one thing to remember, that in ethane and cyclohexane, which one of the following is more stable conformer? So if you talk about ethane here, in ethane, see, firstly, ma'am, what is eclipse? To all those students who have no idea, ma'am, what is eclipse, what is staggered, we are totally dependent on you. See this, right? So, if this is one structure, one is representing the backward atoms, one is dotted will represent the forward atoms. Okay, so here it is some atom here, some atom here, some atom here. If you have zero angle between this, let's say one layer of atom, one carbon is in front, one carbon is in back. The atom that is attached to this carbon, the atoms that is attached to this carbon, these two are representing backwards and front. So one is solid is representing, let's say, backwards, and dotted is representing, let's say, forward. Or you can say more accurately is solid is representing the forward, backward is represented by dotted, right? And one other is when you have 60-degree angle, right? So here what we have, this is called eclipse. Eclipse is, eclipse means when something hides something, okay? So like sun eclipse, right? Like moon eclipse we have, right? So here this is called eclipse, okay? And this is called staggered. Now you yourself feel that, ma'am, this will cause more repulsions. More repulsion always means less stability. That is why always staggered is going to be more stable as compared to eclipse here. Next is regarding the conformers of cyclohexane, right? So conformers of cyclohexane, it's very simple. Conformers of cyclohexane are, let's say you have chair conformer, you have boat conformer, you have twisted boat conformer, right? So out of this, chair conformer is the most stable conformer here. So answer will be, yes, answer will be staggered and this. One more question related to this, I'll tell you that they can ask you. One more question related to this, okay? That is simple. Those who have no idea, those students also can answer this, okay? See, there is one structure which is anti and one is Bosch, okay? So usually what is anti? Let's say these are the two structures. This question also they can ask you regarding propane or especially butane, this question is asked, right? So if you talk about anti-structure, in anti-structure you will have things like this. Like this is CH3 group and this is CH3 group, this is H, this is H, this is H, this is H, right? This is, I am talking about butane. One carbon here, one carbon in front, one carbon in backwards, and in this carbon you have one CH3 group attached. In backward atom also you have one CH3 group attached. This is what I have formed. If CH3 are anti to each other, gauche means they will be at this much repulsions. Okay, they will be at 60-degree angle with each other. Now, in usual case, what we say that because here in anti you have less repulsion, so always anti is more stable as compared to gauche, right? But what makes this question important is gauche effect. Okay, so students, what is gauche effect? Anybody in the chat box, what is gauche effect? Right? So one question they can ask you regarding this simple question, or they can ask you this very, very repeated question, that is anti and gauche. Anti is more stable if there is no hydrogen bonding. Let's say you have a structure. Let's say you have a structure where you have hydrogen bonding, right? Let's say you have a structure where what you are saying is hydrogen bonding. Here you have, let's say you have CH2OH. Here you have CH2OH, right? And here also you have CH2OH. Or directly you can also add OH here. Here also OH can also be there. Like totally your choice, whatever you want to add here, it doesn't matter. What matters is if there is any hydrogen bonding involved, right? So we know that even now, this is the gauche structure, right? And this is the anti structure. But we know that here we will have hydrogen bonding. That is why gauche is more stable, and that is called gauche effect. That is called gauche effect. Very, very important for your exam, right? That is called gauche effect. Where you have hydrogen bonding, that will be more stable. In general case, anti is more stable as compared to gauche. Okay, understood, students? Next question is how many hyperconjugable hydrogen atom does this molecule have, right? So always remember, hyperconjugation is not very, very simple question. Very simple. Yet if you have not gone through hyperconjugation, you will find it, what is this, ma'am? Right? Directly what you have to remember, whatever is the mean thing, that mean thing can be carbocation, that can be a double bond, that can be a free radical, that can be anything, right? The carbon that is attached next to it, the carbon that is attached next to it, this carbon, and this carbon, that is your alpha carbon. First condition is alpha carbon should be sp3 hybridized. Okay, what I am writing? First condition is alpha carbon should be sp3 hybridized, and at least it should have at least one alpha hydrogen it should have. At least one alpha hydrogen it should have. That will make it like it can produce hyperconjugating structures only then. Now we will apply these two things over here. If you draw this structure, students, if you draw this structure here, right, this is the double bond, this is CH3 and this is CH3. Now if you see this, right, I'm telling you the crux of everything, right, that we have discussed. This is alpha, this is the main thing, that is the double bond, right? So this is alpha, this is alpha, this is alpha, this is alpha. If you see how many hydrogen can be there to complete the valency, 2 hydrogen. To complete the valency, 2 hydrogen. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Total you have 10 alpha hydrogens. That means you will have 10 hyperconjugating structures. Always remember, number of hyperconjugating structures, number of alpha hydrogen is equals to number of hyperconjugating structure, and more the hyperconjugating structures, more will be the stability of the compound, right? So here we can write C is the correct answer. Very good. I can see that in the chat box that ma'am 10 is the correct answer. Very good. Next question is here. Now this is, I would say, from one of the most important reactions and most important reagents of your organic chemistry that is repeatedly asked in the exam, right? So first is 2-bromopentane is heated with potassium ethoxide. Now let us see how many of you actually identify this thing. Potassium ethoxide is what, students? Let me know in the chat box. Are you able to identify what kind of reaction is this? Ethoxide means C2H5 ONA, that is ethoxide, right? Potassium means K, here it will be, right? Now this thing, ma'am, what kind of reagent is this? What kind of? Very good, very good, very good. So here it is nothing ethanol. Do you know This reagent hello, 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 hello. I'm so sorry. I'm so sorry. Where I was when I was teaching you this. I am so sorry, ma'am. No audio. Oh, oh. See how consumed I get when I'm teaching. I have no like host. Like, what is going on? Or I see bored and reactions. That's my energy when I solve organic chemistry, physical chemistry, inorganic chemistry. The kind of energy that you should have in your exams, right? No, nothing I see when I am solving the questions. Okay. So everybody, now let us see this. Okay, I'll again solve this for you. Again, I'll do this for you, right? So basically here what I was talking about is that here you have potassium ethoxide. That is C2H5OK. That is nothing but alcoholic QH. Now you have two kind of reagent. One is aqueous QH, other is alcoholic QH. So if you talk about alcoholic QH and aqueous QH, let us draw the compound firstly here. That is 2-bromopentane, right? So now here, now what if we are using KOH, but that is aqueous, right? So directly it will do the substitution. So Br will be substituted by OH, no worries, nothing, right? But what if here you have KOH alcoholic, right? The reagent is C2H5OK. This just to confuse you, they have given it like this, right? Otherwise, what you will do here, here directly you will eliminate the dehydrohalogenation. One halogen will be eliminated. Now the question is, ma'am, here you have CH3. Here you have CH2. So two products can be formed here. If you replace hydrogen from this side, this product can be formed. And if you replace hydrogen from this side, this product can be formed. So here, which product you will choose, A or B? Everybody let me know in the chat box. A or B? We will choose this product, not this product, because according to Schiff rule, more alkylated, the one in which double bond has more alkyl groups attached, that is preferred, right? So that is the major product. So answer will be, now here again the question is whether trans or cis will be formed, right? So I can see the answers in the chat box that ma'am, trans is formed here. Reason is because trans always has less repulsion. If you see, this is your trans, this is 1, this is 2, this is 1, this is 2. One more question I am telling you here, right? One more question I am telling you here regarding GI, right? See, if they ask you which of the following shows geometrical isomer, this is 1, this is 2, this is 1, this is 2, right? So beta, in this case, remember one thing, let's say this is 3 or let's say this is 4, okay? Remember one thing, 1 should not be equal to 2, 3 should not be equal to 4. If you're talking about geometrical isomers will be present only then. Geometrical isomer means cis and trans. If you have two same atoms on the opposite, that is trans. If you have two same atoms, right, side by side, that is called cis. Okay, so trans will have less repulsion. That is why we will answer C is the correct answer here, right? Not cis. This is where students can get confused that which is the correct answer here, right? Next question is based on the stability of the carbanion. Now students, one rule I want all of you to have it in your head, that should be crystal clear in your head, that is BARHI. Everybody spam it in the chat box, BARHI. Ma'am, what is this Barhi? Trust me, this will make questions of stability of intermediate, like in seconds you can solve the questions, and trust me, you will not have any confusion after that. You can easily solve this. Sometimes we know all the effects, still we are not able to understand which will be more priority, right? So this means back bonding, this means aromaticity, this means resonance, this means hyperconjugation, and this means inductive effect, right? Okay, this is aromaticity, this is back bonding. Now, firstly, we will look for back bonding, right? Is there any back bonding in any of the compound? Back bonding, ma'am, means what? In back bonding, like you have oxygen here, and here you have lone pair, and here you have carbocation. One is electron rich, other is electron deficient. That is back bonding, right? That is called back bonding. Or you can have one boron here and one carbanion here. Now, carbanion is electron rich, but boron, we know that from inorganic chemistry, boron is electron deficient. That is also back bonding, okay? Just remember, electron rich and electron deficient, if they are on the adjacent position, then back bonding will happen. Here we can't see any electron deficient atom in place of next to the electron rich, right? So that is back bonding is not possible here, right? Next is aromaticity. Can you see aromaticity should follow PCC? What is PCC? Planar conjugated. From this question, I am revising the full GOC, right? I am revising full GOC, right? That you should apply here. PCC means planar cyclic conjugated, right? So if you see here, planar cyclic conjugated, that is there only in this compound, which is complete conjugation is present. Cyclic it is planar also. Electrons are 1, 2, 3, 4, 5, 6. It has 6 pi electrons. That means 4n plus 2 pi electron it has. That means it is aromatic in nature. For this, students, always remember one table. I am drawing it for you on the side part here, right? That is, if you have important charts, I am giving you for your exam, right? Let's say you have PCC. If PCC is followed, if PCC is not followed, then it is non-aromatic. PCC is not followed, maybe it's not planar, it's not cyclic, it's not conjugated, it's not plain, non-aromatic. If PCC is followed and there you have 4n pi electrons or 4n plus 2 pi electrons, this is anti-aromatic and this is aromatic in nature. And if you see the stability, aromatic, then you have non-aromatic, then you have anti-aromatic, is the least stable compound. If you see any compound, they have given you stability of intermediate, any compound comes out to be anti-aromatic. That will be least stable among all of them, right? Least stable compounds are anti-aromatic compounds. Understood? So here what we will say, that fourth is going to maximum stable. So this is eliminated, this is eliminated, right? Okay, students have answered C is the correct answer. Let us see that, right? After this, let us see if there is any resonance here. Resonance is present over here, right? So that means after that you will have third. Then let us see hyperconjugation. In carbanion, you don't have hyperconjugation, right? In carbanion, hyperconjugation is not valid, right? Unless and until you're talking about minus H, which will not be there in your syllabus, right? So last part is inductive. So here we know that this is carbon, which is 2 degree, and this is carbon, which is primary. And we know that in the inductive effect, which is more dominating, see, simple thing is, if something, beta, one more thing I am telling you about your carbanion stability, I am writing it here, right? I am writing it here. Remember that if you have negative, if you have, let's say, negative, if you have something negative and you are donating the electron, somebody is already under stress. If you are under stress, I am giving you more stress, you will be like, ma'am, please go. I don't want more stress, right? If I come here and start wasting your time, you will be like, ma'am, I don't want to listen to you, right? So here, if I am teaching you something which is useful for you, right? I am taking away stress from you. then you are more stable here, more happy, right? So negative needs negative. That means a carbanion needs something which is taking out stress from them. Then it is becoming stable. And if you have carbanion, then if you give the electron, if someone is poor, you give the money to them, they will be happy, right? But if you take the money from them, they will be unhappy here, right? So here what we can see that in the carbanion, here you are giving the electrons with one set with one CH3, and here you are giving the electrons from two sides. Definitely this will be unstable. So second will be less stable as compared to first. So answer is A is the correct answer here. Right? It needs less electron. It wants that I am already negative. Don't give me more electrons. I am already full of electrons. Right? So that is the reason B is going to be the correct answer. Is that clear to everybody? Very good. Very good. I can see your energy in the chat box. So that is B is the correct answer. Very good. Right? Okay. Super example. Yes. Now you will remember this forever. That okay. Negative means stress. Positive means money. Okay, just remember this for your exam, right? Acha, one more thing regarding what kind of question they can ask you from GOC. This is what I told you, that when I'm saying that this is going to be your important session, that means not only questions, but I'm going to tell you some important paper leaking questions I'm going to tell you, right? So this is the HA, right? Same kind of question they can ask you based on acid. Rather than giving you carbanion, they will give you some HA. We know that if they ask you the stability here, remember that more is the stability of this carbanion, more will be, this will be a better acid, right? Acidity depends on the stability of carbanion, and stability of carbanion, you have already answered that, ma'am. We can easily answer that, right? Okay. Next is, ma'am, pKa value is inversely proportional to acidity. Remember that. Okay. Next important thing is basicity. If they ask you basicity in any question, remember that basicity is directly proportional to number of, or you can say directly proportional to electron availability. Electron availability. If on that species you have more electrons availability, that will be more basic in nature, right? Directly you can answer that, right? Okay. Now that was about GOC, how they can ask you the questions based on GOC. Now one question is based on annulenes. Now tell me in the chat box, how many of you have studied annulenes? Annulenes is a part of aromaticity, anti-aromaticity and non-aromaticity, right? Usually what we see, ma'am, annulenes are very, very difficult. No, beta, they are very easy. I'll tell you how, right? Annuline is monocyclic, like you have benzene, right? Benzene is the example of 6 annuline. The number of pi electrons or the number of carbon will represent the annuline number. So we call it 6 annuline because it has 1, 2, 3, 4, 5, 6 carbons. This is called 4 annuline because it has 4 carbons. Okay. So according to that, we name the annuline. Now you will have always even number of annulenes. From 4 till 14, you can have your annulenes. In fact, till 18, you can have the annulenes. From 4 till 18, you can have the annulenes. But remember one thing, right? What you have to remember? The non-aromatic annulenes. Non-aromatic annulenes, what are these? 8, 10 and 12. Just remember 8, 10, 12, that's it. Right? Don't make too much pressure of annulenes in your head, right? If they ask you very simple and direct question, they will ask you 8. If you see 8 means 1, 2, 3, 4, I think that is going to be 1, 2, 3, 4, 5, 6, 7, 8, right? This is your 8 annuline. It does not exist as like this. Rather, it exists in a tub-like structure like this. Okay, it exists in a tub-like structure like this. That is why it is non-planar, hence it is anti-aromatic. So they can ask you why 8 is, non-aromatic because of its tub-like structure. 10 and 12 are non-planar and that is why they are non-aromatic. Reason being because of their hydrogen repulsion, or you can say angle stream. Ma'am, what about 4, 6, 14, 16, 18 annuline? You didn't told us about that, right? So now regarding other annulines, what you have to remember is number of carbon atoms. Let's say they ask you for, they are asking you for 14 annulenes. 14 annuline means it will have 14 pi electrons. Number of that annuline will represent the pi electrons. 14 pi electrons are fall into the category of 4n pi plus 2. If you put 4n plus 2, 4n plus 2, if you put n is equals to 3, 3, 4, 12, 12 plus 2 is 14. That means it is going to be aromatic in nature. This is what I'm telling you. If they ask you 18 annuline, don't learn anything that, okay, 18 annuline will be what, ma'am? We forgot that in the exam hall. You don't have to learn anything. That is 4. If you see 4n plus 2, again, if you put n is equals to 4, that is 18. Right? Again, it is aromatic annuline. Let's say, ma'am, let's talk about 16 annuline. 16 annuline has 16 pi electrons, so it will be 4n pi if you put n is equals to 4 here. Right? Okay, that's how you will answer this. Is that clear to everybody? Is that clear to everybody or not? Right? So maximum the amount of question that they can ask you from GOC that I have covered from one question only. Right? Okay, students, is that clear? Right, everybody? Now, next question is ring expansion, ring contraction, and ring carbocation rearrangement. Okay, students, ma'am, we can't do this, ma'am. Please, ma'am, easy question you tell us. I'll tell you, I'll make this easy for you. You give me just 2 minutes, okay? I'll make this easy for you, right? Now, do you know one thing that in SN1 mechanism, SN1, 2, just remember 1, 2, 2, 1, 1, 2, 2, 1. What do you mean by that? If you have one SN1 mechanism, that means it is a two-step mechanism. In two-step mechanism, you will have carbocation, then nucleophile will attack, right? So SN1 mechanism means there will be formation of carbocation here. That is clear, right? Now, if you put this here, if I draw this and if I take X negative from there, I'll get this carbocation, right? Now, this is only possible if it is a SN1 mechanism, right? Now here, ma'am, what is ring expansion contraction? Simple thing is, if you have positive charge outside the ring, positive charge outside the ring will cause ring expansion. Just write it here. Positive charge, where you want to write positive charge outside ring, then ring expansion. Without thinking, do ring expansion. Ma'am, how do we have to do ring expansion? Very simple. Put 1, 2, 3. Okay, now what you will do? Simple thing is, you will draw the same thing here. But now attach 1 and 3. Okay, ma'am, attach 1 and 3. So I'll attach 1 and 3. Then put positive on 2. That's it. You have your compound ring expansion. That's it. That was ring expansion. Right? So now this does not look good. So rather, because pentane exists like this, so now I will add OH negative because we are adding water here. So I'll add OH negative here and this will be your answer. So answer is A is the correct answer. Right? Okay, so A is the correct answer. One student has answered OH here. We think this should be the answer if this was SN2 mechanism. Because in SN2 mechanism, you don't have any carbocation formation. In carbocation, there will be ring expansion, there will be ring contraction. So take care of ring expansion and ring contractions, okay? Right? That I have told you where you will use. Now, I know you are a little bit scared after seeing, if you are seeing this for the first time, then you are like, ma'am, okay, this was a good question, right? So, now, ma'am, will I be able to do that in the exam? Let's see it from this side. This is not the same question. I'll give you the hint. This is a question of ring contraction, right? And trust me, in VITEEE, they don't ask very high level question from ring expansion, ring contraction. Very high level question of ring expansion and contraction are asked in GE Advanced. In VITEEE, the state exam or especially university exams, right? They ask you in VITEEE, good questions are asked. That is why this concept they can ask you, but from a very simple perspective, right? So again, it is SN1 reaction. That means it is carbocation formation. It is there, right? So here, what you will have, this is the cyclobutane, right? Take out X negative here. You will have positive here. Remember, whenever you have on the ring, you have the positive charge, you will apply ring contraction here. Ma'am, how we will do that? Same copy paste that we did in ring expansion. This is 1, this is 2, this is 3. What I'll do? Join 1 and 3. Okay, ma'am, we will join 1 and 3. Now put positive on 2. Okay, ma'am, put positive on 2, right? Now write it beautifully like this. Okay, ma'am. Now you have to add OH negative here. Very simple. OH negative is added there. So it will be 1, 2. This is OH. That is CH2OH. That means C is going to be the correct answer. Let me see how many of you have answered it. Very good, very good, very good. Suresh, Sunita, Shirish, very good, Kritika. Okay, very good, right? Very good. Now, very good. One student has also answered. Shirish is saying that dancing resonance. Very good. Now, this is very stable compound due to dancing resonance, right? This is very stable due to dancing resonance because, you know, like you dance, similarly, this will dance. How this dances, those who wants to know this, how this dances, okay? So, when you're dancing on your one leg, sometimes you're dancing on both legs, sometimes you have one leg up, right? So, how you dance? Similarly, this will dance, okay? So, how it will dance? You will have a double bond shifting here. This will be double bond. This is the positive, right? This is the dancing resonance, or this bond can shift here. It can also look like this, double bond, and this is 1, 2, positive here. So, that is your dancing resonance, right? That is your dancing resonance. How to find anti-aromaticity? C, if it follows PCC, then you have to check for 4 n-pi electrons. If there is 4 n-pi electrons, that is going to give you anti-aromaticity, which are the most unstable compounds. Next question, see, in every question you are going to learn something, right? It's not like repeated questions I am giving you, right? Which of the following alkyl halide is respectively most and least electrophilic in SN1 reaction? Most and least. Now, ma'am, in electrophilic, okay, ma'am, electrophilic you are talking about. In electrophile, that means in SN, least electrophilic in SN1 reaction. Okay, they are talking about SN1. Remember, in SN1, you have the formation of carbocation, isn't it? We have the formation of carbocation here, right? Now, if you see the formation of carbocation, if I take Br from here, carbocation will be over here. This carbon will be carbocation. If I take Br from here, carbocation will be over here. If I take carbocation, Br here, carbocation will be over here, right? They are asking you which of the following is respectively most and least electrophilic, right? Okay. So, electrophilic means some nucleophile is attacking here. That is why it is an electrophile. If nucleophile is attacking here, so this person will be electrophile, that person is a nucleophile, right? So, here, that means I have to find the stability. Least stable, firstly, I'll tell you, whenever this is a bridge head position. This is the bridge head position. This position is the bridge head position. Ma'am, do we have to know everything about this? No. Till your exam, you don't have to know anything like full detail on this. Just remember, if they give you something like SN1 reaction, this kind of thing is given to you, and Br is attached here. That means positive charge will be over here, which is not at all stable. Why? Because this bridgehead position cannot handle sp2 hybridization. It is like I cannot handle sp2 hybridization because of some angle strain it cannot handle, right? That you don't have to get into, right? Just remember, here carbocation or here it is not stable at all. That is the reason first is the least stable here. So first answer we have that C is the correct answer. We have the answer that C. Why third is most stable? Because if you put carbocation here, it is 1 degree. If I put the carbocation here, if I see the carbocation, that will be something like this. Now, students, we know that this is the tertiary carbocation. If I put carbocation here, this is 1, 2, 3. But at this position, it is not very stable, right? As compared to this position and this position is more stable. Right, so answer will be this tertiary is the most stable here. So C is the correct answer. Is that clear to everybody? Right? Is that clear? Okay, one more thing regarding this carbocation, right? That is rearrangement. Okay, that is rearrangement. Students, just remember one thing, that whenever you have the formation of carbocation, whenever you have the formation of carbocation, either ring expansion or ring contraction or sometimes ring formation, but ring formation will not be there in your exam, right? You focus on ring expansion, ring contraction, or carbocation rearrangement. Rearrangement means like you have, for example, carbocation, like this carbocation is formed, right? Now what it will do, this will be your hydrogen over here. This hydride will shift on this position and you will have the formation of this carbocation, that is through hydride shift. That is called rearrangement of carbocation. And whenever you see any SN1 reaction, there will be rearrangement of carbocation. Okay, there will be rearrangement. For example, I'll give you one example here, like acidic hydration. Acidic hydration. If you remember, whenever you add acid, H positive, and then you add water, right? For example, in alkene, you are adding it, you form the carbocation. So firstly, you rearrange it. Only then you form the carbocation. Like in hydroboration, oxidation you follow. I'll also give you two other things here. In hydroboration, oxidation, you follow anti-Markovnikov addition, right? In demercuration, demercuration, OMDM, demercuration, you follow Markovnikov rule. Now, anybody who does not draw Markovnikov, anti-Markovnikov rule, so Markovnikov rule means negative part is attached to less number of hydrogen. Anti-Markovnikov means negative part is attached to more number of hydrogens. Okay, is that clear? Okay, yes, students, right? Oh my God, I'm so sorry about it, right? I told you to give, like, when I told you to give 100 comments over there, now students reminded me that 100 comments are completed. Now you take the lecture. I thought you guys are not interested. If I would have known that you guys are interested, trust me, even if it takes me night, like day, I have taken classes at 11 p.m. also, right? So it just, if you guys are willing to do hard work, I am always there, right? I am always there with you, right? Okay. So now next question is, okay. So if you see this here, now these are the sequence. Here I am taking up questions. Till now we have done enough of GOC. Now we are discussing question where you have, let's say, zinc HCl. First you should remember that, ma'am, zinc HCl is what? Your double bond O is converted to H2 here, right? Zinc HCl. One more thing, this is Clemenzin reduction. Zinc, usually we have zinc amalgam and then you have HCl, Clemenzin reduction. Okay. In Clemenzin reduction, you use zinc, amalgam, then HCl. But if you talk about Wolff-Kishner reduction, same thing will happen. Double bond O is converted to H2. But in that case, what you will have here is the hydrazine. In Wolff-Kishner, you will have NH2. I'm just writing it here. Wolff-Kishner, you have NH2, and then you have QH, that is in the basic conditions you have, right? So directly what you can do, firstly, which thing will be formed? 1, 2, 3. This is H2, this is 1, 2, 3. Now, can you tell me what is this? At a very high temperature, 773 Kelvin, when you use Cr2O3, that is aromatization. Okay, aromatization, that means this 1, 2, 3, 4, 5, 6 membered ring will be converted to benzene ring. Aromatization will happen, and hence the answer will be A is the correct answer here. Okay, A is going to be the correct answer here, right? Next question is very important question, very important reaction, that is, can you guess it? Any one of you who can guess this, right? The major product. Firstly, just guess. Don't give me the answer A, B, C, D, right? Firstly, just tell me in the chat box what is the name of this reaction. Just give me the name of this reaction, okay? Right? Name of this reaction. Let me see who is answering first here. Who is answering first here? Inorganic. We are going to take that. Don't worry, right? So very good. That is, ma'am, aldol condensation, right? So here you have alpha hydrogen, here you have alpha hydrogen, right? So exactly which will happen? Can you tell me? You have two answers. Either this alpha hydrogen will be acidic or this alpha hydrogen will be acidic. Which will be more acidic here? Very good. That is aldol. Now you should understand which will be more acidic, students. So we know that this alpha you have and this alpha you have. So exactly what happens, right? So simple thing is, here you already have what you are doing. It is already taking oxygen from this carbon, is already taking electrons from the benzene ring. You should know the reason why this is more acidic in the exam. Who will tell you that this is more acidic? What if you have taken this more as more acidic? So you should know the logic behind that, right? So this is the benzene. You are donating the electron. This carbon is already very happy. This carbon is already very electron rich. That is why this hydrogen is like, okay, this person is acidic, this person is electron rich, so I don't need to, like, he's not crazy about me. This carbon is like, this hydrogen is not totally fallen like mad in love with me. So this hydrogen will be like, I'll go, right? I am ready to go, right? So this person is not fully committed, so I am ready to go. But this carbon, this hydrogen here, this is alpha carbon, this hydrogen here. This carbon is electron rich because this is electron rich. This this is electronegative. This is electropositive as compared to oxygen. This is electron deficient. Then this carbon is like this. This hydrogen is like this hydrogen here that is on the alpha carbon. He is like, this is electron deficient. So it needs me. That is why it is staying here only, right? So that is why this is more acidic in nature. Once you know which is more acidic, simple thing you can do, right? What is that simple thing? One thing that you can do is, you can make the alpha, you can firstly, this is the alpha carbon, because of these wants to abstract the proton. So this will be CH2 negative over here. And then what you can do, this is the negative part, this will attack over here, electrons will jump here, right? So what you will have, this is benzene, C double bond O, CH2, this is linked to this carbon here, CH2, this is linked to this carbon here, where you have the electrons. That is why this hydrogen will be attached here. So here you will have OH and this is CH3. One part is through full mechanism you can solve this. Other thing is through direct method. Now what is that direct method? One is CH3, C double bond O, H, right? Other is you have benzene and on that benzene you have CO, you have COCH3, right? You have COCH3. Now let us see how I am going to write it. This is a method of aldol condensation. Those who find aldol condensation difficult because of the mechanism, they can do this method, which will give you always, even if they have given you some complicated aldol condensation, you will be able to answer this. What do you have to do? The alpha hydrogen that you are using, right? We are using this alpha hydrogen. You will mark it separately, right? And the carbonyl carbon of other molecule, you will open this separately. Now, beta, what you have to do? You just have to join this carbon with this carbon, right? Join carbonyl carbon with the alpha carbon. So this is CH3, this is C, and this will be converted to OH. Because this hydrogen will be shifted here, this is converted to OH here. So this is OH, this is H, this is CH2, this is C double bond O, this is benzene. Okay, that's how directly you can answer this, right? My benzene is little bit funny, so I'll just have to write the benzene again, right? That is your benzene. Now, remember one thing, this is aldol part, right? You also have to use condensation. So from alpha and beta position, take out OH and H here. So what you will have in the end, this is CH3, this is CH double bond CH, this is CO, and this is your benzene. But sometimes in the option, they don't condense the thing. They don't take out water. They just, the options are just related to this thing, right? So we have to see what are the options that are given to you over here. The options are related to OH only. So that means you don't have to eliminate water here, right? So directly answer will be C is the correct answer here. Understood, everybody? Understood? Yes? Okay. Chal. Now, next is Now we go through Wurtz reaction. How many of you know Wurtz reaction? Everybody, thank you, thank you. Thank you for the lovely comments. Thank you, Seher. Thank you so much. Now, 1 bromo, 3 chloro. Now, students, see this. We all know what is Wurtz reaction, right? Ma'am, sodium you add. Ma'am, ether you add. What we do? Ma'am, unsymmetrical is not symmetrical as possible. You have, ma'am, Rx. Ma'am, from here, R is formed through free radical mechanism, right? Okay. Now, what I used? Free radical mechanism. Very important thing I'm going to tell you here, right? Okay. So, they are saying 1 bromo, cyclobutane, this is 1 bromo if this is bromo, 3 chloro if this is chloro, right? Now, they are saying on reaction with this, it will give you what? Students, so first is just remember it follows free radical mechanism, right? So, free radical mechanism means homolytic cleavage here, homolytic. Ma'am, I don't want to get through this homolytic. Ma'am, my brain is not that much working. Okay, your brain is not working, don't worry. Right, just put 1 dot, 1 dot. Like this bindi, you put two dots here. Right, so here it is 1 dot and this is 1 dot. Right, just remember that like Diksha Mam always has bindi on the forehead, that unicorn that always is on the forehead. So that is how unit dot is always on the forehead. That is how you will have this dot dot over here, that is free radical. Now, students, they cram that, okay, this is going to be what, ma'am, okay, this will join. No, you should remember that this will follow inter or intra, right? Okay, see, always inter is preferred, right? That means only one molecule will join together to give you the answer. So that means this C is going to be the correct answer here. Then, ma'am, why you told us intra? You want to confuse us or not? No. If let's say your interproduct is anti-aromatic. Let's say your interproduct is anti-aromatic. Then you will use intra. Ma'am, is there any example of that? One thing you should be clear on, inter and intra, both situations are possible. Preferred is intra. Intra means in one molecule only those two dots will join and that will give you one bond. That is preferred. But this is becoming, let's say, you have one compound that is, let me just think about any compound. Okay, you have this Br and you have this Br. Okay, this is the compound that is given to you. They are saying that this is going through Wurtz reaction. Okay, that means you'll be like, okay, ma'am, this is going to form something like this. One dot here, right? Now, the question is, ma'am, if it goes through intra, which is preferred, it will join together and it will give you this kind of product. Now tell me, is this aromatic? Is this anti-aromatic? Always intra is formed. But if you have, with intra, if you are getting anti-aromatic compound like this, anti-aromatic, which is, it is having 4 pi electrons, then this is not preferred. Then you will have to use inter. That means 2 molecules, these will join together. How they will join together? Like this. They will join together like this, and that will give you the new compound here, right? That is how the product will be formed. Okay, students, got it or not? Is that clear? Simple it is, not complicated, right? Okay, so it's not complicated, right? So I think that's it. Now, next question is Williams-Son synthesis, a very, very repeated question. Ma'am, you have given us the answer. I'm so sorry. But here you have to predict. See, Williams-Son synthesis is Rx and you have RONA. Roxa, Rona, Roar, right? So, Roxa, Rx, RONA. So, this Na and X will be eliminated. You will have ROR, that is ether here, right? Okay. Now, one thing to remember here, if you see this here with NaH, it will have the formation of RONA. This is nothing but this is Rx, right? And here it is giving you nothing but ether. So that is why it is called Williams-Son synthesis, William-ether synthesis reaction. So answer is, I think all of you have answered it, that is B is the correct answer, okay? B is the correct answer, right? Okay. Now, next is, I think, yes, we have done that, right. Okay. Now, next is consider the reaction. So this reaction, right? Why I have picked up this question? Because here 2-3 important reactions we can revise from here, right? First is, if something like this is given to you, right, you should know that tolerance, this is nothing but tolerance test, right? And here you are using copper at 573 Kelvin. Now students, I am giving you some important thing here, very, very important regarding your oxidizing nature. So if you have 1 degree alcohol, you have 2 degree alcohol, you have 3 degree alcohol, right? So one is, if you have 1 degree, 2 degree, 3 degree, first case, second case, and this is the third case, right? These 3 cases are very, very important for you, right? First case is mild oxidizing agent. Second is strong oxidizing agent. Third is copper at 300 degrees Celsius. Right? So these are the 3 cases from where they ask you very direct, simple questions, right? In between also, right? So everybody, I want to see that in the chat box also, how many of you remember that? If you see the first part here, that is 1 degree. 1 degree alcohol in mild is going to give you aldehyde. 2 degree is going to give you ketone. 3 degree will not show any reaction, right? With strong oxidizing agents, like you have Jones reagent. Jones reagent means you have CrO3 plus H2SO4, 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 right? Like you have KMNO4, right? Okay. Here you have CrO3 simple, or you have PCC, or you have PDC. These are mild oxidizing agent. Tollens reagent is also mild. Felling is also mild. Okay, so I have written all the reagents here, right? Now, this is going to give you, 1 degree is going to give you carboxylic acid. 2 degree will give you ketone only. 3 degree will not give you anything, right? Now, last one is when you have copper. Copper with 1 and 2 degree will give you mild answer. That is aldehyde and ketone. But if you have 3 degree, this tell me students, if with 3 degree what it will give you? With 3 degree it will give you which thing? Everybody with 3 degree. And how many of you have liked the session? Right? How many of you, let us see. How many of you have liked the session? See. 417 are watching, 417 or 437 students are watching, and likes are 320. Right? That is not good. Right? That is not good. Like should be beyond 700 or something till now. Those many students who have come here. Right? Okay, so everybody do like the session. I don't have this habit of asking this again and again, but it feels really happy. Right? I have skipped my dinner also for you. Right? So that is your duty to like the session. Right? Okay. So now, here it is going to give us very good. Can I see that? Yes, very good. That is going to give us alkene. Yashraj has answered that. Ma'am, Yashraj was the first one to answer this. That ma'am, alkene is the correct answer here. Very good, right? Now here, let us go through this reaction again. Right? There is some compound X which is having 1 oxygen. On copper at 3 degree, you should be able to understand that there is some either tertiary, secondary, or primary, secondary, or tertiary alcohol is there, right? Then with that, it is giving tolerance test, mirror is observed. That means silver mirror is observed. Now, remember that tolerance test is given by how many things? It is given by aromatic or aliphatic aldehydes. It is given by alpha hydroxy ketone. Only one ketone that gives tolerance test, alpha hydroxy ketone. I know all of you know aromatic aliphatic aldehyde, but only some of you know that there is alpha hydroxy ketones that gives positive tolerance test. And yes, the questions are asked directly, which of the following will give you tolerance test? You know what, in that case, what they will give you? Alpha hydroxy ketone. And very rare students, alpha hydroxy means you have double bond, on the alpha position you have OH. Alpha hydroxy ketone, right? Okay. Then one is hemiacetal. Hemiacetal also give you ketone. Last one is formic acid also give you positive tolerance test. Oops, formic acid, that is HCOH, right? Okay. Now, here what we will do, ma'am, okay, this we have done. Positive means, in this case, if this many, see, one trick I'll tell you, not even trick, one logic, simple, like common sense I'll tell you here. If specially they have asked you question on tolerance reagent, you should remember this, this and this also, right? If not specially they have asked you this, then you can ignore that. Then definitely they are talking about aromatic or aliphatic aldehydes, right? So here we know that with 2 carbon it's not possible to have aliphatic aromatic aldehyde. So this will be aliphatic aldehyde only. So this is your aliphatic aldehyde. Aliphatic aldehyde. Aliphatic aldehyde is possible with copper at 3 degree. That is possible in what? Aldehyde is possible when you have primary alcohol. Now you know that this is primary alcohol. Ma'am, this is primary alcohol. So answer you already have. This A will be ethanol, right? So A is ethanol, that is your primary alcohol. This is acetaldehyde. Acetaldehyde is CH3CHO. That is going to give you primary, that is going to give you positive tolerance test. That means the answer you can already give. Answer you already have here. But ma'am is here to give you knowledge, right? I am not solving the paper for you here, right? So my duty is not to give you the answer. The answer you can get even from any book, right? These questions are there in books only. You can get the answer anyway, right? You can get, okay, B is the correct answer that is mentioned in the book. What's my duty? To explain you things, right? Because I am present here, right? So this you know how to answer, okay? How to use your brain answering this, right? So that is clear. After this, what they are saying, that you have this thing here, okay? This OH is going to give you some acid you have, okay? See, here you have aldol condensation, right? OH negative on aldehyde, that is going to give you aldol condensation. We know that we have acetaldehyde. Now, students, tell me how aldol condensation will be there. This is, everyone draw it on your notebooks, okay? Draw it on your notebooks. I already told you how to answer this, right? This is CH2 and there is one alpha hydrogen here. One alpha hydrogen here. Now we know that these two things will join. That is, this is CH3. This is C double bond O. This carbon is going to join with this hydrogen here. This is CH. This is your CHO. After that, we will have elimination. Here this will be converted to OH, okay? So this is CH, this is converted to OH. After dehydration, this is converted to CH3, CH double bond CH, right? That is alpha beta unsaturated. Why I solved this? So that you can practice aldol condensation, right? Now only if you have your exam tomorrow also, I don't want to waste even a single minute. I want full revision here, right? Okay, so that is there, right? Next is aldol, we have answered. Now, ma'am, what is this kind of question, ma'am? What is this? In your NCERT, you have a table, right, where you have semi-carbazole, Schiff base, oxime, all of these are formed. That table is very important. Go through that table. If right now, just write it somewhere in your wall or somewhere, write it, that if you have not gone through that, go through that. I'll also send you that table on the JE channel, Vedantu JE channel. Everybody, if you have not, if you have not subscribed to the Vedantu JE channel, that is totally for free of cost. You can see the link in the description. I'll send you all the important PDF and the chart also in that particular channel only. Now, see this thing. If you have some ketone and you have NH2, here you can draw NH2 and this is Z. Z can vary. Z can be hydrogen, Z can be OH, Z can be a big benzene also, anything Z can be, right? So directly what will happen? Water will be eliminated and here you will have C double bond N and this is Z. This is the compound that is formed here, right? Now, if you see in this case, NH2Z, this is the Z part. This is the Z part. This is the Z part. So here what you will have? Acetaldehyde is CH3, C double bond O. So here C, instead of C double bond O, what you will have? This is hydrogen, right? This is your aldehyde. Instead of C double bond O, you will have NZ. Z is this whole part, that is NNH, CONH2. right? This compound is formed. Okay, understood everybody, right? Understood, that is your hydrazone is formed here, right? Yes, everybody. Next, this we have done, right? Like this, we have already done this. NNHCO, CNH3, this is what I have written, right? Let me see if I have written this only, right? NNHCO, yes. Okay, by mistake, sometimes in hurry, I forget one hydrogen, nitrogen, no. So that's why I thought. Next is the heating of phenyl methyl ethers with HI produces. Now in ethers, you have also one very important reaction, that is if you have phenyl methyl, okay, you have phenyl and methyl, one is phenyl, this is O, this is CH3. Now, whenever you add HI, what happens? That this is positive, this is negative. Hydrogen will go to some place and iodine will go to some place, right? Either it can get hydrogen attached, either it can have iodine attached, right? So, what will happen here? This bond, see, either this bond can break or this bond can break. This bond is very difficult to break because of the double bond character, because of the resonance. That is why this bond is not possible to break. That is why you will have the answer, that is phenol plus CH3X is formed. That is CH3I is formed. Right? Okay? Understood? Right? Now, remember one thing more here, that in Williamson synthesis reaction, remember one thing, that primary halide, the halide should be primary. Halide should be primary. Right? You will prefer in Williamson synthesis reaction, halide should be primary. Okay, that is the important part. Right? Okay. Next is this also we have done, this also we have done. Now, students, next part is the heating of this we have done. In the reaction, this is given to you, the electrophile involved. First, you have to tell me the name of this reaction. Students, the name of this reaction. What is the name of this reaction, everybody? What is the name of this reaction? Yes, very good. The name of this reaction is Reimer-Tiemann reaction, right? Reimer-Tiemann reaction. Reimer-Tiemann reaction. Reimer-Tiemann reaction, and this is Reimer-Tiemann reaction, right? But when you have CHCl3 chloroform and NaOH, you have the formation of dichlorocarbene, that is CCl2, that is your D is the correct answer, that is the electrophile here. Can you see there is one more reaction similarly like this? There is one. See, here we know that you have the formation of carboxylic, salicylic aldehyde. Okay, that is formed, right? There is one more reaction, that is Carbylamine reaction, where you use the same reagents, but there you convert NH2 to NC, right? That is why it is also called isocyanide reaction. This RNH2 is converted to RNC in the carbylamine reaction. The reagent is same, the electrophile is same in that case as well, right? Okay, yes. Now students are saying, ma'am, there is one more reaction, that is Kolbe's. That is similar in a different way. Kolbe's reaction, you have phenol and you add here CO2, you add QH or NuH, right? With hydrolysis, it is converted to salicylic aldehyde. It is converted to salicylic aldehyde. One more thing. Ma'am, can I make salicylic aldehyde here? Yes. If instead of this, in phenol, you use CCl4 plus NuH, then also you can make salicylic acid here, right? In Reimer-Tiemann reaction also you can make salicylic acid if you use CCl4. This question they can ask you directly, very simple direct question, like in 1 second you can answer that, right? That if they use CCl4 here, then you can make COH, right? If they use CHCl3, then you will have CHO. If they use CO2 and KOH, that is Kolbe's reaction, that is COH. If they use carbylamine, that is a different, but that is similar to Reimer-Tiemann because of the reagents that are involved here, right? Okay, next question is the structure of intermediate A in the following reaction is, if you see this structure here, this is cumene, right? Now they are asking you the intermediate, that I have told you in the before also, that intermediate also they can ask you. Cumene is very like highly frequently asked question, right? So here what we did, instead of H you will have OOH here. Peroxide linkage will be there. So answer will be A is the correct answer. Is that correct? Right? Next we have is the major product of the reaction. The major product of the reaction. Now if you see this here, whenever you are doing ammonolysis, students, whenever you are doing, this is C double bond O, this is OH, this is C double bond O, OH, right? Okay, so this is, you are adding NH2 here. What will happen? This will be replaced by NH2 and NH2. Then you are heating it. With strong heating, what will happen? This, wait a minute, this, what will happen? This hydrogen and this NH2 here, that will be eliminated, that is minus NH3. And can you name this compound? Can you name this compound? Answer, so I know you already know that what is the answer. You will be left with NH here. Here this is called phthalimide, that is used in Gabriel phthalimide reaction. Here it is, phthalimide is formed. This is used in Gabriel phthalimide reaction, again a very important reaction, right? Which is used for the preparation of primary amines, and that too primary aliphatic amines. Any one of you can tell me what is the reagent of Gabriel phthalimide reaction? Reagents are, first you add KOH, then you add RX, right? Then you add, I think, firstly you add something with K, we add, I forgot that, right? This is RX, then you add, I think, NUH, right? Something NUH. So what will happen? Firstly, this will be replaced by K, right? Or Na, whatever the ion is there, right? Then it will be replaced by R here. Then this bond will break after the hydrolysis. Here you will have ONA, here you will have ONA, and here you will have attachment of H and H, that is RNH2 will be formed. That is why we say only primary aliphatic amines are used here, right? Okay. Next is identify the compound you have here in the sequence. Now if you see this here, this is the CH3, right? Now whenever you are using Cl2H mu, right? Remember one thing, student, this Cl2H mu, this is going to give you free radical mechanism. So it will give you allylic or benzylic substitution. Allylic or benzylic substitution, right? So this is the benzene here. Allylic means what? Allylic means you have C double bond C. The hydrogen here will be substituted. Benzylic means you have benzene here. And to this carbon, if you have any hydrogen, that will be substituted. This is benzylic, this is allylic. Okay, this is benzylic, this is allylic. That means here, this hydrogen that you have here, 1, 2, 3. Hydrogen will be substituted. But the question is, ma'am, how many hydrogens will be substituted? 2 hydrogens will be substituted here. I'll tell you why. Because you want to form CHO, right? So here 2 hydrogens will be substituted. Cl, Cl, and this is H. After this you add KOH. After this you add water here. So this will be replaced by OH, OH. So this will be COH, OH, and this is H. Now what will happen? This OH negative H will replace, and you will have the formation of, basically this is going to happen. This is OH, this is OH. So what will happen here? This will be eliminated. This will be eliminated. This bond will shift here. You have the formation of benzaldehyde, right? You have the formation of benzaldehyde, right? Okay, understood? That is why this is a confusing question, okay? Somewhere you can also take CCl3. You can also take CHCl3. So answer is CH, wait a minute, CHCl2. This is CHCl2, yes. A is the correct answer, okay? CHCl2, 2 chlorines are replaced. Now understand one thing. If you have, in this place, if you have Br2H mu, or you can also have NBS. NBS is N-bromosaccharidamide. Ma'am, do I need to learn the structure? No. Just remember, if in the reagent they have written NBS, that means they are talking about allylic or benzylic substitution, right, with bromine, right? Okay. Now Next is the reaction between benzaldehyde and acetophenone in presence of same question, right? So now this we have repeated so many times, so I will not repeat it again and again, right? So now here they have asked you about the cross aldol. So we know that this is benzaldehyde, this is acetophenone. So we know that here you have alpha hydrogen. Aldol condensation is whenever you have alpha hydrogen. Canizaro is when you don't have alpha hydrogen. So if any of the reactant has alpha hydrogen, in that case, aldol condensation will be there. Because you have two different reactants, that will be cross aldol condensation. Right? That will be cross aldol condensation. The product formed by reaction of aldehyde with primary amine is, right? The product formed by reaction of aldehyde with primary amine. Aldehyde with primary amine. Okay, primary amine. Okay, so simple is just the same we did. This is C double bond O. This is this, right? Aldehyde is CH3 and this is hydrogen here, right? And here primary amine means you have NH2 and this is R here. So what will happen? You will have C double bond O. This is N. This is R. This is CH3 and this is H here. Now what is this called? C double bond O N. Anybody? Aromatic, Schiff's base, ketone, carboxylic acid. What is this called? Yes, very good. That is called Schiff's base is the correct answer here. Right? This is again from that table that I told you. That is very important. Right? Okay. Which of the following reactions is appropriate for converting acetamide to methanamine? Acetamide is what, ma'am? CH3, C double bond O, right? NH2, yes, this is acetamide. Then you convert it into methanamine, right? That means you have to take out, this should be eliminated. The best method is Hoffmann bromamide degradation, right? That means you add Br2, you add NaOH or any base here. Directly this C double bond O is vanished. That is why this is called Hoffmann bromamide degradation, because you have one carbon less is formed here, right? Okay. Next question is nitration of aniline. Nitration of aniline in strong acidic medium also gives meta-nitroaniline. Now this is a very interesting question. Let me just clear this out what we are talking about here, right? 3-4 concepts will be there, okay? So understand one thing, that whenever you are doing aniline. Now firstly, how many of you know that this is ortho-para-directing or meta-directing? Tell me this, if this ortho-para-directing or meta-directing aniline, okay? I'll give you, once you have nitration, what kind of products are formed, right? By the time I want to see that if you are able to answer that whether this is ortho-para-directing or meta-directing, I told you when on the benzene ring, you have directly a group attached that is having the lone pairs, right? Then lone pair it will donate here, that means it is plus M. And plus M is always going to be ortho-para-directing. Very good, very good. One student has answered it, right? Very good, very good, very good. Sahej has answered it, very good. So here what you will see, one ortho product on nitration I am talking about, right? Here you have concentrated HNO3, HNO2 and concentrated H2SO4. Two things I will talk about, bromination also, okay? I can see that in the comments, right? So NO2 and this is NO2. Ma'am, this was ortho-para-directing, but you have 2% ortho product, you have 47% meta product, 51% para. Ma'am, what you are saying, ma'am, this is ortho-para-directing. How can it form meta-directing product? How can it form? Let us see that. So what exactly happens here? This is converted to, in these acidic conditions, what happens? In these acidic conditions, what happens? We know that aniline is a good base, isn't it? Aniline is a good base. How many of you agree that aniline is a good base, right? Because it has lone pair of electrons and lone pair means basicity, right? Now here, can I say that this thing will take out one electron from the acidic medium? Base wants to accept the proton. It will accept the proton, will be converted to anilinium. This question they will ask you, why you have the formation of meta product 47% because of the anilinium ion, which is meta directing. Why it is meta directing? Because it is taking out electron from the benzene ring. When any group takes out electron from the benzene ring, that is meta-directing. You don't need to cram it. Any group take out the electron, meta-directing. Any group gives the electron, ortho-para-directing. So that is why meta product is formed here, right? Okay, ma'am. Okay, ma'am, got it. That okay, that's all. But ma'am, this first question they can ask you that how much nitrating mixture, how much meta product is formed. Second question, why it is formed? Because of the aniline ion. Third question, how you can make one product only, that is para. How you can make only this product here? How you can make that? By doing acetylation. That is, you can add acid anhydride, or you can add acetic chloride here, whatever you want to add, in presence of pyridine, right? Here what will happen? You will have the formation of this kind of product. Now let us see, this question is also asked, okay? In statement based, this question is also asked. Third question they can ask you here is, how you can make para product here? By doing acetylation. In acetylation, what happens? How can you actually prepare para product by doing just acetylation? Because these lone pairs are now busy in the resonance with the carbonyl group. That is why what you will have here after nitration, this is NHCOCH3. You will have NO2 group here. After the hydration, you will have only the para product here. That is not 51, full 100% para product you can form. Similarly, with the same process, you can form mono-bromo para product also by doing acetylation, then adding Br2 here. You can get the para product of bromine as well. Okay, understood everybody? Right, now let us see the question what we were asking you. Nitration of aniline in strong acidic medium also give meta because of, in absence of substituent, no. In electrophilic substitution, no. In spite of substituent, no. Right, in acidic medium, aniline is present as anilinium ion. So answer will be D is the correct answer. Is that clear to everybody? D will be the correct answer here. Correct? Okay. Shall I move ahead? Right? Shall I move ahead? The correct order of basic strength. Now I told you the basic strength here. Methyl substituted amines in aqueous solution. Right? Now students, what I told you for basic strength, see the direct proportionality here. Basic strength means more the availability of electrons. Right? Now, but ma'am, here they are asking you in aqueous medium. That is the different question. Here they are asking you this in aqueous medium. In gaseous medium, you can say 3 degree, then 2 degree, then 1 degree. This is in vapor form or in gaseous medium, right? Because 3 degree has the maximum donating power, electron will be maximum. But in case of methyl, see, in case of methyl, I'll just directly write here. In case of aqueous medium, if you have methyl, it will be, or if you have ethyl. In case of methyl, it is 2, 1, 3. 2, 1, 3. I'll just write it here. 2, 1, 3. In case of ethyl, it is 2, 3, 1. Direct question can be asked on methyl or ethyl. Right? That is the order here. Right? Okay. So answer will be 2, 1, 3. That is D is the correct answer. Next question on your screen is, which of the following amine will give carbylamine test? Carbylamine is given by only primary amines, right? Okay, that can be aromatic, that can be aliphatic. So this is not primary, this is not primary, this is the only primary amine that you have. So C is the correct answer here, right? Okay. Which of the following compounds will form significant amount of meta product during mononitration reaction? Significant amount of meta product. We have seen this, that meta product is formed by aniline here because of the anilinium ion. So answer is D is the correct answer here, right? Okay, understood? Now for all the students here, right? One important thing, if you have your exam, see, I have not finished yet. Here I have yet to complete physical and inorganic. Some important questions I have picked out for you. Hardly it will take half an hour, because physical and inorganic students I have completed here, right? You can go and watch this lecture here, right? You can go and watch this lecture here. Here I have completed physical and inorganic in 2 hours, you can say, right? If you watch this at 2x speed, it will be 1 hour or 1.5 hour hardly it will take you, but all the concepts will be revised here, right? If you don't want to go through any questions here, then students, this is the video section. Here you will see one lecture for physical chemistry important formulas. Wait a minute, let me just show you that. If you see this here, then let me know. Must do this questions last minute. Sample paper, NCERT top questions, organic conversions. Okay, where is that? Why I'm not able to find my own vid lectures? Can you see that? I think, here it is. All formulas in physical chemistry. You can just type physical chemistry formulas, Vedantu JEE English, Diksha Mam. Okay, so you'll get all the formulas in 53 minutes. You can revise for physical chemistry. Very beneficial for your exam, right? At least one day before you must go through this. Then for inorganic chemistry, right? If you don't want to go through this lecture, right? What you do here for inorganic chemistry and for too many lectures we have already taken, right? So here, I'll just show you the important 2-3 important things here in the okay. So here it is. All naming reactions, complete revision for organic chemistry. Complete revision is there. Complete organic chemistry revision. You can see this here. From my handwritten notes only, I have taught you all the naming reactions, right? Okay. So important reagents also I have taught you. Some important reagents don't have any name, right? But they are important, right? Then there is important exceptions that you can see here, right? The important exceptions, right? You can see here all the important exceptions, important lines we have covered here. You can also go through that, right? Now I'll come back to the lecture again. That is your physical chemistry. Some important questions. In detail, I have covered physical chemistry already, right? Now I'll just brush up some concepts here, right? Okay. This is not like a revision thing. This is basically your testing. Okay. Let us see if you are able to answer this or not, right? So if you have attended my lecture before, then I think you will be able to answer this, right? At least I have that confidence on me, right? The Bohr orbit radius for hydrogen atom is approximately this, the radius of first excited state. See, if they are talking about first excited state, that means in orbit, you have to add it, right? You have to 1 plus 1, that is 2. Second excited state means 1 plus 2. Third excited state means 1 plus 3. According to that, you will answer your excited state. Hydrogen atom means Z is equals to 1. Here it should be Z is equals to 1. Now, we know that the radius is R is equals to 0.53 n square by Z angstrom. Because the options are in angstrom, so I'll put the value also in angstrom. Put the value of n and z here and you will get your answer for the radius. Right, student? In physical chemistry, in the detailed lecture also, in direct questions also, in the direct formula video also, I have taken up all the formulas. Right? So, if you don't have enough time, I would advise you to go through the formulas directly. Okay? Next is, which of the following is not permissible arrangement of electrons in an atom? So, not permissible arrangement, they are saying. Not permissible arrangement. So, not permissible arrangement means, you have to see, remember 2-3 things here. L is equals to 0 to n minus 1. So, that means L and n can never be equal. M is equals to minus L, 2 plus L. Right? So, if you see this here, that is not permissible arrangement. So, that will be it is 5, 3, this is not equal, that is not there in any case. But we can see here L is equals to 2, so M should be minus 2 to plus 2. So this is not possible, so that is not permissible. So B is the correct answer. Okay. Next, consider the following processes. So this process is given to you, that is half of A to B, this is given, this is given. Now student, Hess's law is very important, okay. We don't have any as such formulas. I feel even the student who has no idea about what is thermodynamics, they can even solve this. Here you see no chemistry is involved here. This is not chemistry. This is a question of mathematics. Hess's law is not a question of chemistry because reactions are given to you. What you have to do, you have to see how you can form this reaction by using these three reactions. Now, if you add these 1, 2, 3 here, let's say you add here half A plus you have 3B plus you have E plus you have A, give rise to I think A should be multiplied by 2, right? This should be multiplied by 2. If you multiply this by 2, you will get A to 2B, right? Then you added, this is A plus 3B plus 3B, है ना? A plus 3B plus E plus A, okay? Then here you have 2B plus 2C plus D plus 2D, right? Now let us see what we have here. We know that this 3B and 2B will be cancelled. So this will be B here. This will be A. This will be 2A, right? This also we have written. E, it will be E, right? Then here it will be 2C plus A. You need to cancel this, right? So you need to reciprocate this. You need to reciprocate this also, or this one. So let us say directly only, why to use that much, है So I think so, yes, they have reciprocated it. This is A plus 2B. At least one thing will be reciprocated. That is inverse, you will take off one thing. They have taken inverse of this thing. Let us solve it like that only. Here you have A plus 2B. A give rise to 2B because you need to make this formula here, right? And here you have 3B give rise to 2C plus D. You need to delete A here. That means if here you have A, here in this side you should have A. So it is A plus E. This is 2D. Now, if you see that this is multiplied by 2, so this answer will be multiplied by 2. That is, it is going to be 300. If this is reciprocated, it will be minus 350. This is going to remain the same. You need to add these three things here. When you add this, what you get, this is A will be cancelled, right? And here you will have 3B plus 2D, right? Here you have 2B plus 2C plus E, right? So here we know that 2B, this is B plus 2D, this is 2C plus C, right? So that is going to be your answer here. So you just need to add 300 plus 125 minus 350 and you will get your answer here, right? That is based on the Hess's law. No chemistry is involved here. This is direct mathematics. You have to get that equation, right? Next question is, at 500 Kelvin, the reaction N2 plus 3H2 give rise to 2NH3. The Kp value is given to you. Kc they are asking you. So directly the relation between Kp and Kc. Kp is equals to Kc RT delta Ng. Delta Ng, we know that this is gaseous only you have to take. So this is 2 minus 4, that is minus 2. Put the value here, that is minus 2, right? So you will get Kp is equals to Kc by delta Ng, divided by RT square. Kc they are asking you, I feel. So that will be equals to Kp is equals to Kc by Kc they are asking you, right? Okay. So directly you can answer the value of Kc here, right? Okay. That will be delta Ng. So Kp will be this. This is minus 2, na? So directly you can answer it. Kc is equals to Kp multiplied by RT square. You don't have to write it like this. If this is given in RT, sometimes they don't even give you the value of, like, they give you the options in RT only. That is even more easy, right? Okay. So now you have to put the value of R here. Now for R, remember one thing. R can have different values. See, this now in physical chemistry, this is the confusing part. I have seen students even of JEE Advanced, they feel it very, I don't know why they feel it difficult. They get confused where to put the R value where. Right? If things are given in calories or kilocalories, you will have two value here. If you things are given in joules, right, then you will use the value 8.314, that is nothing but 25/3, right? If things are given in, let's say, liter or atmospheric, we are talking about, this is mostly used in solution chapters, right? So here we use point, here we use 0.0821, that is nothing but 1/12, right? So that is how you are going to put the value of R. T will be given to you in the exam, right? Okay. Next is elevation of boiling point is 1 molar solution of glucose is 2K, and depression. See, we know that elevation is TB is equal, depression is want Hoff factor of glucose is given, so want Hoff factor will be 1. So it is Kf into molality. Delta TB. Colligative property is very important. Definitely you will see question based on that, right? So 1 molar, that means Kb. If you see, this is also 2K. Depression, the depression in freezing point is also given to be 2K. So that means delta TF and delta TB are equal, that is 2K, right? So directly you can say Kf into molality is equals to Kb into molality. Right? Here molality of boiling point, if you see elevation in boiling point, so here the molality is given to be 1, right? So here I'll put the value 1, right? This is boiling point, this is freezing. For freezing, the molality is given to be 2. Okay, so this is Kb, this is Kf. They are asking you Kb and Kf. So you have to calculate Kb. Kb is 2 Kf, so answer will be D is the correct answer here, right? Okay, that is not the correct answer. D is the correct answer. I think by mistake it is there. So, D is the correct answer here, right? Okay, D is the correct answer, right? Next, D na? D. Sorry. Okay. Next is the half-life of a reaction inversely proportional to the square of initial concentration. See, direct formulas I will tell you. Those students who are thinking of skipping chemical kinetics, remember these three formulas you remember, right? T half is directly proportional to initial raised to power 1 minus n. If n is 0, 1, 2, order will be given to you. You can calculate the dependency here. Next is if units are asked to you, then what you can do? Mole per liter, 1 minus n per second. N is the order, right? Third is reaction for first order reaction. Don't, because this is, even if you have never studied, like at least for boards you must have studied, right? So you just need to know this. Boards, so you have seen the questions of first order reaction, that is K is equals to 2.303 divided by T log of initial concentration by final concentration. If it is given in percentages, take initial concentration as 100. If it is given in fraction, take initial concentration as 1. Right? So these are the crux of the full kinetics chapter I have told you. Right? What is important, and one more formula that is important. K is equals to K is equals to A e raised to power minus EA by RT. You know, 99.99%. You will see 1 or 2 questions based on any of this formula. Right? Okay, from chemical kinetics. Now let us see this here. They are saying half-life of a reaction is inversely proportional, right, to the square E naught. That means we know that actually the formula is A naught n minus 1. That means n minus 1 is equals to 2 is equal, order is equals to 3. So order is 3. So you just have to equate this A naught 1 minus n, or you can also do this thing. It is 1 by A naught square, so it can be A naught minus 2 here. So you can also write like this, that 1 minus n is equals to minus 2. So ma'am, n is equals to 3. Okay, whatever you do, answer will be 3 is the correct answer. Is that clear? Next. Now here what you have to remember, that ma'am, this question is given to you. Simple thing is, remember that whenever you are given reduction potential, right, that is directly proportional to oxidizing power. Right? More reduction potential, it wants to get reduced, it wants to oxidize something, it has a very high oxidizing power, right? Oxidizing power is high, reducing power will be less. Reducing power will be less. Or which thing will be less? Oxidation potential will be less. Mostly they will ask you, I have seen question on this only. Mostly you will see in previous year question, you must have seen question on this only, right? So reduction potential is directly proportional to oxidizing power here. So if you see this here, ma'am, how to calculate reduction potential? In reduction potential, in reduction, always oxidation number will decrease. In oxidation, always oxidation number will increase. So if oxidation number is decreasing here, right? So here also it is gaining, that means all of them are reduction potential. In reduction potential, it is gaining the electron, right? So here it is what? Maximum reduction potential means maximum oxidizing power. So maximum reduction potential is of CO, so that is maximum. Then you have PB, then you have CE, then you have BI. So answer will be B is the correct answer. Is that clear to everybody? I can see you guys very less answering the questions. Why? Why are you not answering the questions, right? Try to answer it, right? Now, next is given the equation, given the equilibrium constant. So this reaction is given to you. Equilibrium constant is given to you. Calculate E naught value, right? So students, 2-3 formulas you must know, right? One is the formula of delta G is equals to minus NF E naught cell. Very important. Next is this formula. Here they have given you relation between K equilibrium and delta G. That is very important. K equilibrium and E naught cell. That is where these all formulas are there in the physical chemistry formula session. That is a 53-minute session. Okay, you can watch that. E naught cell is equals to 0.0591 by N factor log of Kc. Kc is given to you here. N factor, how you will calculate? Number of electron lost and gained. So if how you will see this, here we can see that Cu is getting converted to Cu2 positive. Ag positive is getting converted to Ag. Here that means it is losing 2 electrons. Here this means it is gaining 1 electron. But number of electrons should be same. So this is multiplied by 2, this is multiplied by 2, this is multiplied by 2. And hence N factor is going to be 2 here. You apply this formula here, you will get your answer directly, right? Okay. Next is very important question. Right now, currently this question is important for you, right? Ma'am, okay, tomorrow morning my exam. Don't worry, I'll just end it in next 15 minutes. You can go and revise physical chemistry formulas, naming reactions before sleeping. I would advise you. Then don't study anything in the morning. Please don't study anything in the morning, okay? So which of the, yes, you can study your important notes just for 1 hour, not more than that, right? Which of the following facts regarding ionic conductance of falling ions is correct, right? Simply remember one thing. Ionic conductivity is directly proportional to size of ion inversely to size of hydrated ion. Why? You know, in mostly students, they remember this by size of hydrated ion. Don't remember by size of hydrated ion, because if the size of ion is small, more hydrated molecules can attach. Then the size of that ion which is having smaller size, the hydrated ion will have more size. That is why hydrated ion and ion has opposite sizes, right? Just remember it from the size of ion. So here we know that Ruby. So this is say friendship. This is Cr, Fa, right? So if you see here, sodium, potassium, and rubidium. Over here, the size is decreasing. So ionic conductivity will also decrease. So you will have sodium minimum, then you will have potassium, then maximum will be your rubidium. So answer will be D is the correct answer. Okay, understood? Next question is, for an electrochemical cell, this question is given to you. Now, why I have taken up this question? See, Nernst equation is very important, right? Very important. Direct formula you will use here, but the problem with students is formula you can see from my formula sheet also, which I have given you. You can see from the revision of 53 minutes of formula also directly. But the application is difficult part in this question. Application you have to see. So see how to apply this. First, you should know that the formula is E is equals to E naught cell minus of, you have 0.059, you can say, or here they have given you 0.6 only, right, divided by n factor log of, this is product by reactant. Now, this representation is given to you. Firstly, pick out the product by reactant. So here we know that Sn is getting converted to Sn2 positive, right? Pb2 positive is getting converted to Pb, right? That means product by reactant is Sn2 positive by Pb. So I can see that here I'll put log of Sn2 positive raised to power the stoichiometry divided by Pb2 positive raised to power the stoichiometry. We can see that here what is happening, 2 electrons, it is losing or gaining. It is getting converted to Sn2 positive, oxidation number is increasing, it is losing 2 electrons, that is minus 2 electron. Here it is gaining 2 electrons. Here it is gaining 2 electrons. So n factor also you can write 0.06, this is also 2. Now ma'am, how do I answer the value of E naught here, right? E naught. So students, for that you should remember this one thing here. Whenever you are calculating the value of E naught, what you have to see, E naught cell will be equals to E naught of cathode reduction potential minus E naught of anode reduction potential. Please don't make this mistake. I know students who know everything. They have done enough practice. This is where they lag behind, right? They put oxidation potential here. Reduction potential you need to put. Ma'am, who will tell us that they have given us oxidation potential or not? Will that be given in the question? See, it will be given in the question, but you have to identify yourself whether it's oxidation potential or reduction potential. See, here you have, if reduction potential means oxidation number should decrease. That is the way to understand, right? So here oxidation number is +2 to 0, it is decreasing. It is also decreasing. That means both of them are reduction potential. Now ma'am, how to tell which is cathode, which is anode? We have justified that both are reduction potential. Who will tell you that which is cathode? Nowhere it is mentioned which is cathode, which is anode. Remember, see, one thing is, if you can see that here you can see loss of electron, here you can see gain of electron. Loss of electron means oxidation means anode, gain of electron means reduction means cathode. But then is there any direct thing also that you can tell us? So always remember that in this case what you have, here, this is the salt bridge. Always before the salt bridge this is anode, after the salt bridge this is cathode. Always it is like that. Always it is like that. AC. Right? You turn on the AC, that's how you remember AC. Right? Okay. So that means in this cathode, instead of writing cathode, can I write this? Instead of writing cathode, I will write Pb2 positive to Pb. Here I will write Sn2 positive to Sn. You can calculate the E naught value here, put it here, all the other things I have told you, directly you can get your answer. Is that clear to everybody? Right? Is that clear? Rest is the calculation part that you can do yourself. Right? This may seem dangerous to you, but this will not seem dangerous to you. Understood? If you know what I am teaching you, if you know how to apply this, easily you can solve the questions based on Nernst equation. Right? Okay. Next is, according to Arrhenius equation, whenever there is Arrhenius equation, one thing should come in your mind, that is Ek is equals to A e raised to power minus Ea by RT. Right? Now the graph is between log of K and 1 by T. Right? For graph based question, what you need remember, convert it into ln of K, this is ln of A, this is minus Ea by RT. Convert it into log base 10, that will be log of K is equals to log of A minus 2.303 Ea by RT. Ma'am, I don't know how to do the conversion, but then you have to cram this, okay? Then it's not in my hands that you have not done enough CBSE practice. So this was there in CBSE also. If you have not done any, you have not gone through any coaching, you have not done, like CBSE or state board, any state board exam that you are in, right? For example, you have not done any competitive exam preparation. This was there in your board exams, right? This you must have done, right? So till here, now the competitive part I'll tell you, right? Now this is Y, always it is Y versus K, okay? Just remember, wait a minute. Okay, always it is Y versus X. Okay, so here it is Y versus X means here this is Y is equals to, this is Mx and this is C, right? So X is given to be 1 by T, so I'll take 1 by T as X. So that means M is equals to, slope is going to be minus 2.303, 2.303 EA by RT, right? Not only R. C, that is intercept, is going to be log of A. So slope, if you see, that is going to be negative, that is intercepting at log of A, right? And this is log of K, this is 1 by T. Ma'am, what if they have asked here ln of K versus 1 by T? Then you will take this. Then this will be your Y, this will be C, this will be X, and then this will be your M, that is slope. Right? So here answer is minus EA by 2.30. Wait a minute. I should have divided it here. I don't know why I multiplied it here. I'm so sorry, beta. I should have divided it here. By mistake, I have multiplied it here. Right? This is EA by 2.303 R. Because here you need to multiply. When you're converting now, here you will multiply by 2.303, then you will divide the whole term by 2.303, so that will be 2.303 over here. So answer will be, this is your slope, that is minus EA by 2.303 R, that is A is the correct answer here, right? Okay. Next question is regarding inorganic chemistry. Now let us quickly see some questions of inorganic chemistry here, right? Inorganic chemistry, students. First is, inorganic chemistry is not a big deal to gain marks, right? So first is, you should do VBT, then you should do VESPER. Basically, ma'am, do we have to do all the theories? In chemical bonding, do hybridization, right? All the previous year questions of hybridization should be on your tips. Same questions are repeated. They are not going to form a new molecule just for you, right? Okay. Then you should go MOT, right? MOT is a must do, right? These two from chemical bonding. Then from coordination, application of VBT, one molecule, how to calculate magnetic moment, all of these, how to calculate the hybridization. Then CFT you must do. These are the 4 topics that are must do. After that, what you can do? Exceptions of inorganic chemistry you can do. If you have done this, easily you can get full marks in inorganic chemistry. It is definitely not a very big deal to get full marks in inorganic chemistry. Predictable. They don't even change how they can change the compound, right? They are not going to make new exceptions for you, right? Directly you can solve it in seconds, right? So here it is, XCF6 on complete hydrolysis yield X, the molecular formula. So now here you should know this reaction, right? What my idea is, in VITEEE, they will rather give you directly, they will ask you the hybridization rather than giving you the reaction. But if they want to ask you some 3-4 tough questions, then this can be one of them. This is tough only because of this reaction. Otherwise, directly how will you solve it? So we know that xenon. Ma'am, how to apply this? Central metal atom, you see, in central metal atom, see in what group it belongs to. It belongs to group number 18. So 8 is the outermost valence electrons, right? Now here, we know that oxygen always forms a double bond, right? So it is 1, 2, 3, 4, 6 electrons are occupied in bond pair. So it has 2 electrons. That means 1 lone pair you have. Now if you calculate sigma plus lone pair, sigma is what? Sigma, how many sigma you have? 1, 2, 3 sigma. 3 sigma, lone pair is 1, that is 4. This should be on your tips that, I'm writing it here, if you have 2, it is sp. If you have 3, it is sp2. If you have 4, it is sp3. 5, it is sp3d. 6, it is sp3d2. Right? So here, This is linear, trigonal, planar, tetrahedral, trigonal, bipyramidal, octahedral. That should be on your tips. Okay. Now, this is 4. That means sp3. Geometry is tetrahedral. Can you see here what they have asked you? They have asked you the shape. Shape you should know. So, for shape, what we will do? See, simple thing. I just have molecule here, so I'll just show you so that you don't do mistake in the exams. See, these like 3D structures I have explained in the full detailed video that I have completed. Important concepts. You can, if you're like, ma'am, I want to see this concepts in detail, then you can go through that video, right? Okay. So now here, this is tetrahedral. Take out one bond pair, put lone pair here, because in shape you don't consider the lone pair. So what we will do, this is nothing but this is pyramidal shape, right? So what we will do, this is xenon, this is one lone pair, this is 1, 2, 3, 4, 5, 6. So that is your pyramidal shape here. So answer is XCO3 and the shape is pyramidal shape here, right? Don't confuse it with planar. This is the planar shape. Planar shape is in one plane, right? You don't have any angle with my hand here, right? But in pyramidal shape, you can see the angle with my hand here, right? So that is the pyramidal shape, right? Okay. Next is, which of the following is paramagnetic in nature? So now if you see the paramagnetic nature here, paramagnetic nature, students, see this, very important. Paramagnetic nature means two things you have. One is diamagnetic, one is paramagnetic. Paramagnetic means you should have at least one unpaired electron. Ma'am, okay, unpaired electron. Ma'am, how we will solve this? Unpaired electron, students, very simple thing, right? You will apply MOT here. Whenever these kind of molecules are given to you, you will apply MOT, right? So here, unpaired electron you have to solve. See, firstly, tell me the total number of electrons. Here you have 14 electrons. Here you have 6 plus 6 carbon. It is 12 electron. 14 minus 1, that is 13 electron. This is 16 minus 16 plus 2, that is 18 electrons. Right? Firstly, I am writing one thing for bond order, right? Because sometimes they ask you bond order, right? So what if number of unpaired electron and bond order is given to you? Bond order. Then what you have to remember? Then just remember that with 14, you have 3. Okay, 14 has 3 bond order. So when you go below 16, 17, 18, or when you go above, that is 13, 12, 11 and 10. Okay, 0.5 will be subtracted. So this will be 2.5 to 1.51. Here also it is 2.5 to 1.5 and 1. If they ask you the bond order, ma'am, if they have asked you unpaired electrons here, right? So what you will do, you will have to make the diagram here, right? So if you see this, here you have 14, 12, 13, 18. So I'll just write it here, 12, 13 and this is 18, right? Now one by one we will solve this, right? For 14, if you have equals to or less than 14, it is going to be 1, 2, 2, 1. 2, 1, 2, 1. Right? Out of 14, subtract kk star. Kk star is 8 electrons. See, if you have more than 8 electrons, always subtract 8 electrons here. There is no need to draw full diagram here, right? So here it is kk star, you will subtract here. So I'll just divide it into 4 batches so that we can draw everything here. So this will be 8 electrons. Minus 8, it will be 6 electrons. So 1, 2, 3, 4, 5, 6. So this is definitely diamagnetic because it is having no unpaired electron, right? C2, we know that this also is less than 14. So it will also follow 2, 1, 2, 1, right? So 12 minus 8 is equals to what? 4 electrons. So it will be 1, 2, 3, 4. Again, it is diamagnetic, right? N2 positive. If you see N2 positive here, N2 positive, whenever you have ions, don't look for the electrons in the ion. Look for the electron that is there in the neutral species. In the neutral species of N2, you have this thing, that is 14 electrons, right? So here we have taken out one electron here, that is 1, 2, 3, 4, and this one electron here. That means this is the unpaired electron. That's why this is paramagnetic in nature, right? One thing you should know that O2 is paramagnetic. That is the reason, that is the point of this theory. So this is O2. We know that that is having 16 electron, that is greater than 14. That means it will follow 2, 1, 2, 1. So I'll just write it here, less or equal to 14 or equal to 14. It is having 2, 1, 2, 1, 2, 1, 2, 1, more than 14. It is having 1, 2, 2, 1. Okay, more than 14, it is having 1, 2, 2, 1. So what I'll do here, this is 1, 2, 2, 1. Okay, so from this 18, I'll subtract 8 electrons from KK, that is 10. Now fill 10 electrons, 1, 2, 3, 4, 5, 6. Wait a minute, 1, 2, 3, 4, 5, 6, 7, 8. 10 electrons, na? 10 electrons. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Right, so that is why this is also diamagnetic. Okay, we have completed whatever they can ask you. How long this lecture is? Maybe 10 minutes more. Okay, so we are proceeding towards ending the lecture only. The complex having a spin only magnetic moment. So now the questions are related to spin only. Now remember one thing here, but mostly the questions that I am teaching you right now are like most probable questions in your exam. And if you see this here, this is number of unpaired electron, this is magnetic moments, right? So what we will do here, number of unpaired electron is 1, 2, 3, 4, 5. Okay, then magnetic moment will be 1.7, 2.7, 3.8, 4.9, 5.9, something like this, right? We know that the formula is mu is equals to under root n plus 2, where n is the number of unpaired electrons, right? But we don't need to use that formula in competitive exams. Directly you can use this, right? Now here you will see that this is 2.82. That means directly we can know that number of unpaired electron is 2. Now you have to see which of the following has unpaired electron is 2. Now if you see unpaired electron 2, nickel, this is in zero oxidation state. Nickel in zero oxidation state. Nickel is atomic number 28. Now let me know in the comment section who have confusion regarding the electronic configuration, right? If you have confusion regarding electronic configuration of 3D series, ma'am, please write the electronic configuration of 3D series from scandium to zinc. Then let me know here, I'll write it. Okay, if you already know, that's good. If even one student says, I'll write it, right? So in nickel, we know that it is 3D8, that is 4s2 3D8 here, right? So here, we know that 8 electrons you have here, right? So carbonyl, if you see, there is 0 unpaired electron will be there, right? Because carbonyl is a strong free ligand. What will happen here? You will have B here. It will be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This is 2 plus 8, that is 10 electrons in total, right? Next we have this thing. This is x minus 4 is equals to minus 2. So x is equals to plus 2. That is, you have total nickel 2 positive. That means 2 electrons you will take out from 4s. That is 3d8, right? Okay. Now here, if you draw the diagram, this is the diagram 1, 2, 3, 4, 5. D orbitals you have to fill. This chlorine is weak field ligand, so it will be 1, 2, 3, 4, 5, 6, 7, 8. You can see that there are 2 unpaired electrons, so already answer will be B is the correct answer. You don't need to see the other, right? Okay. Can I see that? I can't see any of you asking for the electronic configuration. That means I think you guys are okay with the, like, ma'am, we know the electronic configurations, right? Okay. So next is, which of the following ions is colored? See, DNF block and coordination chemistry. If you don't know the 3D series electronic configuration, you won't be able to pass that. Trust me on that. You won't be able to do that if you have no idea about the electronic configuration. Now, if you see colored, now here we have given copper. Copper is what? 4s1 3d10. Copper positive is what? Take out from 4s1 electron, it is 3d10. That means no dd transition. See, if you want to see colorless, either it will be d0 or it will be d10. So it will be colorless. We want colored, so it's not colored. It's not colored. Then we have Cu2 positive. It is 3d9. That is definitely colored, right? Because here you can see 3d9, which is not under the category of 0 or 10. So that is not colorless, right? That is colored. Titanium, we know that titanium is T, that is T means titanium, it is 22, 4s2, 3d2, right? So here you take out 4 electrons, it will be 3d0, that means in that category. Vanadium is 23, that means 4s2, 3d3. You take out 5 electrons, it will be 3d0, that is under that category. So answer is B is the correct answer. Okay? Yes, everybody? Right? Okay. Next we have this very important question regarding the oxidizing nature of KMnO4 with Ki. So what you need to remember that when you have Ki in the acidic medium, what will happen? In the alkaline medium, what will happen? One, it is converted to I2, other it is converted to IO3 negative. So in the acidic medium, it is converted to I2. In the alkaline medium, it is converted to iodate ion, that is IO3 negative. In all the other oxidizing, like when you talk about SO42 negative, it will do the same thing for acidic and alkaline, but this is the different part here, right? Okay. Yes. So that's it. That's it. I'm again asking anybody. Let me see if any one of you is asking. Students, please, if you write in English, that will be better for me to understand, right? Okay. Let's find unity in diversity, right? Okay, let's find unity in diversity. Let's not be any language barrier on this channel. That's the reason this channel was created, Vedantu JEE English, right? So that all the students, right, who are preparing for different exams, they should not, it should not be like because they don't know Hindi or because they are not good in their regional language. That is the reason they are not able to understand the topic. So if you know English, good to go, right? And we know that English is very important if you're preparing for engineering exam, right? So you'll end up in some good MNC, that obviously even the placement interviews are in English, right? So that's why I'm saying, please, I'll be happy if you write the comments in English so that even I can understand what you are saying, right? Okay. Which thing you are asking me to explain? This one, this question, or this one? What you are asking me, Ashwin? What you want me to explain? Ma'am, can I get session PDF? Session PDF now you want to get, see tomorrow too you will get, because I don't think so team will be available right now, right? So team will not be available right now. So right now you can't get the session PDF, but by tomorrow it will be updated. But I'll ask, right? Okay, I'll ask them to create the session PDF on priority, and I'll ask if they can do it today itself, right? Okay, okay, I'll ask the team. I'll just message them now only. Right? Now, which question you want? We are asking, ma'am. Very good session. Thank you. Ma'am, configuration, please. Okay. Members was a super chat, ma'am. Where is the super chat? There was a super chat. Ma'am, there was a super chat. Where was the super chat? Arun, where was the super chat? Tell me, you can now give the super chat. Arun. Okay. Yes. Now, if you are asking me about this question here, then in the acidic medium, this I negative is getting converted to I2. In the basic medium, this is getting converted to IO3 negative. That is a factual question. Okay. Then here what you have, if you're asking me about here, always remember that whenever you have, let's say whenever you have colored compounds, there will be DD transition, right? So if you have colorless compound, the electronic configuration will be D0 or D10. We know that in Cu positive it is D10. In titanium 4 positive, this is titanium 4 positive. This is vanadium 5 positive, right? That is 0 or 10. Only in this case you have 3D9, that is why only this is color. Now for those students who are looking for the electronic configuration, see this here, right? Ma'am, thank you so much. Configuration question, please, ma'am. Configuration question is nothing, you see this here. This is Sakti Kar Man Fi Ko Niku Jan. Okay? Now here, just write 4s everywhere. Right? Write 4s and 3D everywhere. 4s, 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 4s. Write 3D everywhere. 3D, 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 3D ma'am, 3D ma'am, 3D ma'am, 3D ma'am, 3D ma'am. Now ma'am, what you have to do? This is from 21, 22, atomic number I am writing 25, 26, 27, 28, 29, 30. Now you see how to write the electronic configuration. 2, 1, 2, 1, 2, 2, 2, 3, 2, 4. For chromium, skip copper, right? Okay. Then you write manganese 2, 5, iron 2, 6, cobalt 2, 7, then 2, 8, then 2, 9. This I told you to skip. Chromium and copper is exceptional, okay, that you have to skip. Zinc is 30, ma'am. Should I write 4s3, 3d0? No, right? S can only have 2 electrons, right? So 4s2, and what you are left with? Because here before this you have argon, so this will be 2 and 10, right? Now here, this exception will be, this should be 2 and 4. But because of the half-filled configuration, this will be 1, 5. This should be 2 and 9. But because of the fully filled configuration, this will be 1 and 10. Right? Okay. Understood? Right? That's how you will answer the electronic configuration. Once you know the electronic configuration, right, then you can easily answer question like this. What you have to do, whenever you take out the electron, you take out the electron from 4s orbital, not from 3D, right? So we are taking out the electron from 4s, right? Then from 3D you have 0. We are taking out the electron from 4s and 3D, then you have 0, right? Okay, understood? Ma'am, tips. So for your tips, students, see, depends upon when you have your shift, right? If you have your exam tomorrow, then I would really advise you, it's almost 10. So I will advise you, just go through the formulas. Please don't read anything new. Go through the formulas of chemistry, physics and mathematics, right? We have taken sessions here in the live. You can see our VITEEE session over here, right? Wait a minute, let me just show you that VITEEE session over. This is my organic chemistry reaction, right? You can see that is just for 1.5 hours, right? This is my exceptional video, right? Exception, all exceptions in one go. You can watch that, right? And this we have taken important concepts here of VITEEE, right? Let me just show you that important concepts of VITEEE. This was the important 50 questions. I will just ask you to go through VITEEE important concepts here. 6 days ago, we have taken most important concepts of maths, physics and chemistry. You can go through that, right? That will really help you. And you know what? We have also taken, right, as you can see here, Shreyas sir has taken for English and aptitude as well, right? Because that is already also there in your syllabus. So go through this English and aptitude. That is just for 1 hour. Go through that because the questions are not difficult in VITEEE regarding aptitude and English. General question, if you have gone through once, you will be able to do that, right? Okay, then I think that's it. If you're able to do these questions, that will be enough for you, right? Okay, that's it. Now the only thing is, VITEEE long concept sessions were for those students who don't have their shift tomorrow. Who have their shift tomorrow, don't do anything, just revise the formulas, that's it, and sleep. Sleep, revise the formulas, sleep. That's it, right? Okay. For those students who have days left for their exam, then don't worry, go through these important sessions that I have told you. You will be able to manage, right? Don't worry about that, right? And for those students who want to get themselves enrolled in the offline coaching students, right? So those students who are thinking about taking a drop and get enrolled to the offline coaching. So students, at this page, you will get your Vedantu city center nearby your city. You can see Tamil Nadu, Andhra Pradesh, Telangana, Punjab, Maharashtra, Delhi, Bihar, Odisha, Rajasthan, Puducherry, Karnataka, Uttar Pradesh, right? So depending upon which is near to you, you can visit the center and you can tell them that, okay, I am a student of Schiff sir, I am a student of Namrata ma'am, Diksha ma'am. You can tell them and they will surely help you. You just have to take our name there, right? And the counseling, the guidance will be given to you. And you can also get the scholarship depending upon your marks, right? So you have 40% scholarship on JEE NEET courses, right? You can start and enroll yourself to offline coaching. And if you're looking for 90% scholarship, then you can go for this IV SAT program, that is Instant Vedantu Scholarship Admission Test, right, students? So here, ma'am, how can I get 90% scholarship here? That is, register yourself here and give the offline. See, in offline, you have to give the test, right? 90% scholarship is a big deal. We want to see you that, yes, you have done this only by yourself, right? No cheating, nothing was there, right? So based on that, we will give you the scholarship up to 90% if you have scored good in that exam, right? So I would advise you, if you're thinking about a drop, right? Even if you're not thinking about a drop, right? Let's say you're not thinking about a drop, right? I am sure even then, give this test. At least get yourself enrolled here. Once you have completed all your exam, give this test, right? That would be your backup plan, right? That would be an amazing backup plan, right? Okay. And for all those students who are preparing for JEE Advanced, then students, wait a minute. Where is this? Where am I? Yes. Okay. So if you see this here, in the description box, students, in the description box over here, right, you will see different test series, right? Then if you're looking for JEE Advanced batch, then JEE Advanced Rank Accelerator book is there for all the students who are preparing for JEE Advanced. And you know what? I'm also, in fact, Schiff sir, Namrata ma'am and your Diksha ma'am, we are going to take up session on this rank accelerator. Top 20 questions we will take up from this book, right? So you can see the questions from this book and you can see the value of this book. We have already taken so many sessions here based on this, right? Which will give you the value of this book, right? So here, this book has really interesting, amazing questions which will open up your brain for more interesting questions, right? Okay, so that is for JEE Advanced students. And if you are someone, ma'am, I am totally, ma'am, my brain is not braining, ma'am, right? JEE Advanced is very near. What to do, ma'am? I am not able to solve the question by myself. Then what you do? Enroll to Eklavya batch over here. So this Eklavya batch is basically for JEE Advanced aspirants to pick up you from this level of JEE Mains to JEE Advanced level. Here, previous year questions, Eklavya questions, doubt sessions are there in the class itself. You can go through that batch and this will really help you to fill that gap that you have in JEE Mains and JEE Advanced. Okay, so that is there. Everything is in the description. If you have any other question, then let me know in the chat box. Any other question in these session, how much marks we get? See, I have to given you all the marks here, right? I have given you all the important topics, right? It totally depends. If you are able to apply whatever I have taught you in the exam, you might get full marks also in chemistry, right? It's not like I have like only taken up some questions. In one question, continuously I'm speaking from past how many 2 hours? I think more than 2 hours. So this will help you, right? So don't worry about that. You have gained marks, but that application part is important, right? To brush the concepts, please go through the physical chemistry formula video. Please go through the naming reactions. Please go through the exceptional video. This will hardly take you 2 hours if you watch that in 2x speed. That will brush up the concepts for you, right? You can see if exceptions you don't want to do, you can ignore that, but at least go through naming reactions and physical chemistry formulas, because that will cover the full physical chemistry and full full physical chemistry and organic chemistry. Regarding inorganic chemistry, I have taken theories part here. Rest you can see my important concept video, or you can just, even these questions were enough if you're brushing the concepts, right? Okay. Yes. Okay. So I'll now ask the team, right? I'll message the team that they provide you the link here only today itself, but I can't promise you that. But yes, tomorrow morning it will be provided. Okay. Okay, then bye bye. Take care, students. All the best for your exam. All the very best. And please don't panic in the exam. You should have your one strategy, and that strategy is be relaxed. Okay, there will be so many things that will be odd in the exam hall, right? You already have given so many other competitive exam. You might have given JEE mains also. The same thing will be there. You will have some unexpected things, not only in the paper but also by the examiner also, right? So those things will definitely disturb you, will definitely create disturbance in the exam hall. But your main target should be, you should try to keep as calm as possible and try to do those questions that you know. Firstly, do those questions, right? Then go for the difficult ones. Please don't get disheartened in the exam that, okay, this question I don't know what to do. If you feel that, okay, this question I don't know, just skip that question. It's not like every question is going to give you the same mark, right? So if you, even if you solve difficult question or easy question, that is going to give you the same mark. So I would advise you, firstly solve chemistry, because in the previous shifts, student has told that, okay ma'am, that chemistry was very easy, right? It was predictable questions were there, right? So firstly try to solve chemistry questions, then go for whether you like maths or physics. According to that you can choose, right? Okay then, bye bye. All the best for your exam. All the best, and do your 100%. Don't be panic. Don't have stress. Anything. Just relax right now. Please take good sleep right now. Don't wake up the whole night. Right, that will ruin your exam. If you have exam tomorrow, take proper sleep. Your brain will only work when you have proper sleep. That's my advice to you. Lots of love, and this heart is for you. All the best. Now, this is Diksha Kaushal signing off. Have dinner and sleep and take rest. Bye bye. Take care. See you all in the next class. And while I am ending this, I want all of you to write it down in the comment section. Hashtag, hashtag, hashtag chemistry done. Okay, hashtag chemistry done. If after watching this lecture you have confidence, then write down hashtag chemistry done, chem done, in the comment section. I'll wait for your comments. That will also give me energy that, okay, you guys have benefited out of this lecture and you have revised everything in this lecture. Okay, bye bye, take care, see you all the best.